So let's look at a question where we're going to apply our complementary identities as well as our trig identities. So let's say they ask you to find the value of sine 25 cos 65 plus sine 65 cos 25. Now, this is the problem. I don't know the value of sine 25 or cos 65. How do I approach this? So, obviously, because the question has been given to you, it means it can be solved. So this is where in this chapter you need to start thinking that, okay, if I look at my two angles, one thing does strike out. 25 and 65 are complementary angles. They add up to 90 degrees, 65 plus 25. And so that is a hint that, okay, I need to be using complementary angles. On top of that, I see that, forget about this, if I just deal with this one in complementary angles. Let's say I convert cos to sine. This will be written as sine 90 minus 65, which will turn into sine 25. Now that's sine square 25. And so that tells me that basically this is a question where A, I must use complementary angles, and B, I'm looking for my sine square plus cos square identity. So that is how we're going to approach it. Traditionally, what we do is pick one of the angles, either 65 or 25, and change the other one. I am going to pick 25 to stay the same. So now this is, of course, sine 25 doesn't change. Cos theta is equal to sine 90 minus theta. I want to change 65. Sine theta is cos 90 minus theta, and of course I don't change 25. Now here we're not going to move back to sine cos 65, which was our identity, that sine 90 minus theta is cos theta. I'm going to actually calculate this. So that I rewrite it as sine 25 into sine 25. Similarly here I have cos 25 into cos 25. Now of course this is nothing but sine 25 whole square, which as we know notation wise is written as sine square 25. This is of course cos 25 whole square, which will be cos square 25. Now this is sine square theta plus cos square theta, which is clearly equal to 1. So I have found the value of sine 25 cos 65 plus sine 65 cos 25. Initially, it will be a challenging chapter simply from the perspective that you need to figure out and learn what you need to do. But as you practice, I will say this again and again as we do more questions, because this chapter, above any other chapter, unless you keep practicing, you will not get comfortable and you will not be able to quickly identify what you need to do. But this is the basic thing. When I see complementary angles, that means I need to manipulate them and manipulate them in an appropriate way to get to an identity. By that I mean converting them all to sine will not be helpful. This would be sine 25 as we've done. This would be sine 65 sine 65. That's not going to help us. Sine square 25 plus sine square 65 is nothing. It's not an identity I can use. So we convert carefully. Let's look at a slightly bigger, more complex question which involves all of our identities along with knowing the values of our functions. So now we have this. Obviously much more work, many more angles, many more different angles. But again, we analyze it calmly and move on from there. Now if I look at my numerator first, I have cosec square minus tan square minus cot square and plus sec square. Now as I start thinking of my identities, I know that I have an identity that connects cosec square and cot square. I also have an identity that connects sec square and tan square. Now, what are those identities? I know that sec square theta is equal to 1 plus tan square theta. Which clearly means sec square theta minus tan square theta must be equal to 1. I have plus sec square 27 and minus tan square 27. So by rearranging my numerator, I actually come here. Similarly, cosec square and cot square had the same relationship. So cosec square minus cot square would also be equal to 1. So when we deal with these questions, we'll rearrange them to make it convenient for ourselves. Because it's addition and subtraction, I can move it around how I want to within reason. So if I rewrite it as cosec square 55 minus cot square 55 plus sec square 27 minus tan square 27. You can see here, of course my signs are still correct. I have positive cosec, positive sec, negative cot, negative tan. The plus is not causing any problems. So in the next step, I will simply simplify this and say, well, this is nothing but 1. This is also nothing but 1. Now, in the same step, let's also analyze our denominator. What should stick out to you is cot 45 is actually an angle that I know. It is from my table. 45 is an angle that I need to know. Unfortunately, cot 45 is nothing but 1. Furthermore, 13 and 77 are complementary. 37 and 53 are also complementary. Now, while you might not automatically understand what to do here after converting to complementary, let's do it and see what happens. Now, I'm going to leave this side untouched and change that side. Now, this will turn into tan 13, like I said, I'm not changing it, tan 37, cot 45, which here I'm actually just going to put its value. It's 1, I know what the value is. Now tan 53 will be cot 90 minus 53 or cot 37. You can do it directly like this in the exam. In fact, you will kind of have to, otherwise it will take too many steps. It will become very, very long. And tan 77 will become cot 90 minus 77, which is nothing but cot 13 degrees. Now, coming to the next step. As we said, we know that sec square minus tan square is 1 and cosec square minus cot square is 1. So the numerator simply turns into 1 plus 1. And in our denominator, we know that cot is just inverse of tan. So this is tan 13, this is tan 37. We multiplied it by 1, of course, for the cot. This is 1 upon tan 37 and this is 1 upon tan 13, which, as we can clearly see, if I do this multiplication, 13, tan 13, tan 37, tan 37, all get cancelled. My denominator simply becomes 1 and my numerator is 1 plus 1, 2. And so I get my value of this identity that I had here. So like this, you have to understand the questions when you look at them. So as I said, the more questions you do, the quicker it will jump out to you that, okay, I have sec square, tan square, I have cosec square, cot square. These are complementary tan angles which will turn into cot angles, which will turn into inverse, which will get cancelled. I have a value, of course values you just need to remember. So once you get comfortable with that, once that sticks out to you, the chapter becomes a lot more straightforward. So by doing more and more questions, you will get comfortable with it, and these things will start becoming more obvious to you. Now let's move on from value-based questions to, as I said, the largest chunk of the chapter, the hardest part of the chapter, which is actual identity proofs, LHS equal to RHS. So here we have our first proof questions, which are, we have to prove that tan theta plus cot theta is equal to sec theta cosec theta. And then another question, which is that sec square theta plus cosec square theta is equal to sec square theta into cosec square theta. Now, these problems, especially when you look at it, here in this one in particular, I have tan, cot, sec and cosec, but I don't have squares. We know that tan and sec are associated, but only when they're squared. Same for cot and cosec. So when you deal with a question like this, there is one simple golden rule, and most questions you will follow this rule, which is take one of the two sides, let's say I take the LHS, and convert the LHS into sine and cos format. So we write LHS. Now tan theta plus cot theta, which I will rewrite as, we know tan is sine upon cos, as we discussed when making the table. And we know that cot is cos upon sine. Okay. Now looking at this, there isn't too much else I can do other than take the LCM. Now the LCM will just be cos theta into sine theta. This one will get multiplied by sine. This one will get multiplied by cos, which will in turn make it sine square theta plus cos square theta upon cos theta sine theta. Now sine square theta plus cos square theta is 1. So this is 1 upon cos theta sine theta, and 1 upon cos theta is just sec theta, 1 upon sine theta is just cosec theta. Since it's multiplication, not an issue at all. So turns into sec theta cosec theta. And hence this is of course our RHS. So I have proven that my LHS is equal to my RHS. Let's solve this in the same way. I take my LHS. Now sec square is 1 upon cos square. In that sec is 1 upon cos. So sec square will also be 1 upon cos square. Similarly, cosec square will be 1 upon sine square. Now once again, can't do too much else. Let's take the LCM. The LCM itself will be cos square theta into sine square theta. This gets multiplied by sine square theta. This gets multiplied by cos square theta. Once again, this is our direct identity. Leaves us with 1 upon cos square theta into sine square theta, which, like this one here, simply becomes sec square theta cosec square theta, which is again our RHS. Now these types of questions are generally considered convert to sine and cos questions. We call it that because what is the basic approach? You convert to sine and cos, then manipulate it to get to what you want. All questions are not as simple as this. There are some questions that require much more imagination, but they all follow this basic principle, which is convert into something that seems familiar, work on it, and get to the other side. And one golden rule that I'm going to say now, and you're going to see me apply in every question we do, when I'm solving one of my sides, whether it's the LHS or RHS, in every step, I keep in mind what is my RHS. Because that is my target. That is where I need to take my proof to. So keeping these principles in mind, let's look at some more advanced problems in trigonometric identities. Here's another question that we will deal with. Now, we have to prove that cos A upon 1 plus sin A plus 1 plus sin A upon cos A is equal to 2 sec A. Now, when we look at this question, one thing that immediately jumps out to us is that these are just the reciprocal of each other. Beyond that, there really isn't anything else that we can directly do. There's no identity that's immediately visible to us. So, what we will do is, clearly because the LHS is bigger and more expanded than the RHS, we will work on the LHS and simplify that by doing the only thing that we can do right now, which is to take the LCM. So let's see what happens then. Now, when I will take the LCM, the first fraction will get multiplied by cos A. So this will turn into cos square A. The second fraction will get multiplied by 1 plus sin A, because that is the LCM. So this will in turn turn into 1 plus sin A whole square. And of course, our LCM will be nothing but cos A into 1 plus sin A. I've just written cos A first just because it's just easier for me to write it like this. Now, one tip for you is that do not expand this. Do not multiply cos A inside your bracket. Most of the time, we will eventually cancel something from the denominator. But first, let's look at the numerator. Now, here, I actually will have to expand something because there's really nothing else I can do. And I also know that if I expand 1 plus sin A whole square, I will get sin square A as one of my terms. So I have cos square A and sin square A. So that's what we'll do. So upon expanding, of course, cos square A stays the same. I'll get 1 square plus sin A whole square, which is just sin square A, plus 2 into 1 into sin A, just A plus B whole square, plus, now 2 into 1 into sin A will be nothing but 2 sin A. And of course, our denominator remains unchanged. Cos A into 1 plus sin A. Now, like I said, the immediate thing that should jump out to you is that cos square A plus sin square A, when we put them together, is just equal to 1. And so, I will replace them with 1, which will turn into 1 for cos square A plus sin square A, plus 1, which was already here, plus 2 sin A upon cos A into 1 plus sin A. Now, if you observe, 1 plus 1 will just become 2. So, this will become 2 plus 2 sin A. I take 2 common. I'll be left with 2 into 1 plus sin A divided by cos A into 1 plus sin A. And now you can see what I was saying, that things get cut. So 1 plus sin A and 1 plus sin A get cut. We get left with 2 upon cos A, and of course cos A in the denominator just means 2 sec A, which is our RHS. So as we can see, by taking the LCM in this question, opening up our numerator and manipulating it with our identities, we simplified, we did not separate our denominator, managed to cancel, and then got left with our result. So when nothing is obvious, taking the LCM is a very good and a very correct start to the question. Let's look at some more, slightly more complicated questions on LCM. Now let's look at this question. So as I said, it is a slightly more complex question than what we've been doing so far. What we see here is that in the RHS I have sec and cosec, LHS I have tan and cot, but I don't have any squares. So when we deal with such questions, it means you should convert into sine and cos. Now this is of course just theta, so it might not be a question with letters, which is fine, not a problem. So let's start off and see what happens. We will come to a step in this question in which we use a very important technique, so keep in mind and keep watching out for that. Now of course tan is nothing but sine upon cos, so as I deal with the LHS I get sine theta upon cos theta upon 1 minus cos theta upon sine theta for cot theta plus cos theta upon sine theta divided by 1 minus sine theta upon cos theta. Now of course this is your whole denominator, let's put it in brackets so that we don't get confused, and this is our whole numerator. This will become sine theta minus cos theta upon sine theta. This will become cos theta minus sine theta upon cos theta. It's division of a fraction, so it will get reciprocal and multiplied. Here sine theta will come to the numerator, here cos theta will come to the numerator, everything else will stay. Therefore this turns into sine square theta upon cos theta into sine theta minus cos theta. Why? Cos theta was already in the denominator and this is sine theta minus cos theta. Plus, similarly here we get cos square theta upon sine theta into cos theta minus sine theta. This is where we are going to use that skill I was talking about. If I carefully observe my denominators, I have cos theta into sine and sine theta, which is fine, they're in multiplication. This is sine theta minus cos theta. This is cos theta minus sine theta. If this had been sine theta minus cos theta, only this would be the difference between the two denominators. So taking LCM would have become very easy. We can create that for ourselves. If I take minus common from this, it will become sine theta minus cos theta. This plus would change to minus. Because it's an entire fraction, I have taken 1 minus out. Upon doing that, our LHS turns into sine square theta upon cos theta into sine theta minus cos theta minus cos square theta upon sine theta into, and like I said, this flips to sine theta minus cos theta. And the purpose behind doing this is now if I take the LCM will be simply sine theta into cos theta into sine theta minus cos theta. Meaning my first fraction I only multiply with sine theta and my second fraction I multiply with cos theta, resulting in sine cube theta minus cos cube theta upon sine theta cos theta into sine theta minus cos theta. Now you might be thinking that why did I do this? I had sine square plus cos square here, but I can't put them together, right? Because they had different denominators. With this, I got an easy multiplication. And now, although this is not a direct identity that we know from trigonometry, it is an algebraic identity. It is a cube minus b cube. Let's expand that, write the numerator in terms of the identity and see what we get. So this is where we were. Sine cube theta minus cos cube theta upon sine theta cos theta into sine theta minus cos theta. As I said, while this is not a trigonometric identity, it is an algebraic identity. A cube minus b cube. You might recall that a cube minus b cube is equal to a minus b in brackets multiplied by in brackets a square plus b square plus ab. So that means sine theta minus cos theta a minus b into a square plus b square plus ab, not 2ab, which is just sine theta cos theta, upon, of course, sine theta cos theta into sine theta minus cos theta. Now once again, we see the benefit. Sine theta minus cos theta got cancelled. Furthermore, sine square theta plus cos square theta will be converted to 1. So this will simplify to 1 plus sine theta cos theta divided by sine theta cos theta. Now when I look at my RHS, I see I have 1 plus sec theta cosec theta. Should I break my numerator about my plus? I will get 1 upon sine theta cos theta plus sine theta cos theta upon sine theta cos theta. This is nothing but 1. This is nothing but cosec theta sec theta and of course if I just rearrange it, I write it as 1 plus sec theta cosec theta, I have obtained my RHS. So this is actually a very important question, because anytime you have a question where you see that you have two fractions, one of them has sine theta minus cos theta and the other one has cos theta minus sine theta, this is the question where you take minus and simplify from there. The second reason why this question is so important, it shows us that we must be very comfortable with our algebraic identities. If we're not, it can cause problems. So this is a very large question. It is a typical 4-mark question. So make sure you're comfortable with it and keep these tricks in mind.